I have a filter here that is actually a bit more of interest for this kind of thing, because it instead of having one point of resonance, one resonant frequency, it has two resonant frequencies. So if I feed this sawtooth into this other filter, I now have it in a mode where it is simple, one basic cutoff. So now I add the resonance. This is one resonant peak. Now I add another resonant peak. And when you have two resonant peaks, or three resonant peaks, or even more resonant peaks, then you get more talkative effects in the timbre of the sound. So, and especially with the, if you go to the low pitch mode, you can also do percussive effects.
Is that similar to a cone filter in a way?
No, not really.
No.
Basically, what it does is it's two parallel filters. But the outputs, the two parallel filters basically get the same input signal, but the outputs of the filter are not added to each other, but are subtracted from each other. And what you then actually do is you start to subtract the passed bands. So if this is our frequency spectrum, this is like very low and this is very high. One of the filters, for instance, is sort of set to pass these low frequencies and block these high frequencies. Now, if the other filter is set to this, and if you would add them, you would sort of get a curve like this. But if you don't add them, but you subtract them, you actually get a curve that goes like this. Then if you add resonance, then the resonant peaks of both would sort of go up like this, and you get a bandpass filter. So basically what you do mathematics with pass bands, which is a bit different from a comb filter. Because a comb filter basically works with a delay, a time delay, and then a cancellation of the original signal and the delayed signal.
Which is why you get the thinner sound as you increase the resonance.
Yeah. So if I go back to audio range, there is actually a point where when both curves are equal, they almost cancel out. Then if I increase the resonance, that goes even a bit further. So basically what you create is a bandpass filter where you have separate control of the low cutoff and the high cutoff positions. And like a true bandpass filter, if they're the same, the sound would disappear, because if the bandwidth is 0, it would not suppress sound. Another advantage is that you can actually let the knobs cross each other. It doesn't matter which of the two bands is tuned higher as the other, Because there's another way to make a bandpass filter, and that is to first have a low-pass filter and then a high-pass filter. But then you have the problem that if your low-pass filter is tuned lower as your high-pass filter, nothing comes through. So that means that your high-pass filter has always to be tuned lower as your low-pass filter to pass any sound. And else you lose the sound. With this methods, you don't have that problem. What actually happens if one of the filters goes over the other is that it will reverse the polarity of the output signal, but you don't hear that. You would hear that if you sort of later mix it with other signals, then you can actually sort of use it to make sort of phase cancellations. But in practice, this is just a very interesting filter because usually you can freely play with knobs and always have sound. I like it very much. Okay.
Is it coincidence that this looks like a cat, Rob?
No.
Thank you.